people are either shy or haven't had training. Or it's been
reminded me, I'll probably know.
Arctan?
Huh?
Arc Tangent?
Oh,
No? Okay.
I don't know. I know what you're talking about, but I don't know how to do it.
Some of the words are familiar?
Yeah.
Alright. It's okay, it's not required for this class. So generally on a two-dimensional problem like this, I would ask for the magnitude of the force, and not ask you to find the angle. It is legitimate for me to go draw the resultant, in which case you would, get close. There's a problem on the test where I had, I think, 4 vectors coming off of a single spot, and what's the total force, and you draw it out as best you can. There's a wide range of acceptable. So let's do one with adding 3 forces together. Let's see how well we can wing this. I got something right here being pulled on. By those, assume, I'm going to try to draw that straighter. I'm going to make that one. Right. Assume that they are drawn proportionally, that the longest vector, the longest arrow there represents the biggest force, and the smallest one represents the smallest force. So the sum of these vectors, you start with one of them, and it doesn't matter which one you start with. I'm going to start with this one. And I'm going to try to draw it the exact same direction at the exact same length. Okay, I wasn't sure whether you were doing it in your head. All right. If done right, those are the same length and in the same direction. Are they?
You try.
Was that?
You tried your best.
Yeah. All right. And then that one. I can still see the grease spot right there. And then, maybe we'll just keep going clockwise here. This one right here. And then this one right here. Now I have not answered the question yet. If I left it like this, and some students have, if I left it like this would be the equivalent in elementary school math of what's 1 plus 2, and you answered 1 plus 2 equals 1 plus 2. It is not incorrect, but it does not really answer the question. So we actually have to put down an answer. It's from where we began to where we ended. There's my resultant right there in black. If I then, to make it more like the test problem, said that this represents a 4 Newton force, what's the magnitude of my resultant? Well, if that represents 4 newtons, and this, what does that represent? Well, how many of those will fit in here? 1, 2, it looks like roughly 3. So the magnitude of my resultant is somewhere around 4/3 of a newton. Just because that's about a third of the length of that. Like,
So I'm not understanding what you did. I mean, I saw what you did, but why did yours turn into a shape?
when I'm adding vectors, I'm using a graphing method. I do head to tail. So
Okay.
I just started with one of them, and so that becomes my new starting point. Then I just picked another one.
Okay, and so each of us might pick a different starting point, so our shapes might look a little different.
Absolutely.
And the answer will be the same.
It should be. Now, if we were all freehanding it, odds are against it, but in general, it should be something like this.
This that you're recording, is that gonna be online?
Pardon?
The video that you're recording is gonna be online?
Yes.
Sorry.
Yep.
So, everything you've done on the board, from the right angles, that's gonna be on here, on this test, or that's what we need to know as well, like this right here.
Yeah, this stuff right here, yeah, this is fair game.
Okay.
I think officially the book does this in chapter 5, but we're talking about forces, vectors, we're taking the slow route in chapter 2. Other questions right now?
We're gonna need to know how to do that
To add them together? Yeah, you should understand head to tail method.
in the graph.
The question is, if I gave you this, should you be able to do this? Is that the question?
I don't know, I'm just kinda confused with the graphs, like, I don't understand,
How I got this?
or either of them.
Well, this right here, I just arbitrarily put down 4 vectors that I wanted us to add together. So I've given no context for this. This is just, I have 4 vectors that we're adding.
Okay.
This is just how you add them, like draw one, then you draw another, then you draw another, then you draw another.
Okay.
I feel like I haven't really addressed your concern though.
No, it's okay. That kinda makes sense, cause I thought that was relevant, cause you just said that, you just drew it.
Yeah, that just, there's a test problem similar to this. That was the segue to it.
Okay.
Is that a 3 under the 4?
Yes.
Okay, so the 4 in, and then you get the 3 from the 3 additional lines?
No, the 3, because this right here, when I did my rough estimate, my resultant's about that long, and I can fit about 3 of them inside there.
Oh, okay.
It's a really crude estimate for the size of this. This is about 1/3 of that length. Other questions?
Okay, so that 4 in, take that out, if you take that off, and like, I guess like, the one you have on this side, like, what, like, yeah, what if that's 2 in or whatever, can that still be in that answer some kind of way? I mean, I'm just trying to just figure out.
So if this had been 2 newtons,
Yes,
then I would have taken that and I've gone,
okay,
it looks like it's slightly less than 2 of them.
okay.
So, in which case it, 0.45. I believe on the test problem I said, get close. I know what you're thinking. You're thinking, we haven't had enough vocabulary, so how about a couple more words? Good. Let's do it. These sides right here, these are known as perpendicular components. And so I'm not standing on my head, I'm right up here. Perpendicular components of R. Because in adding these together, I could have just added the perpendicular components. I could have gone through and figured out, well, how far to the left, how far up do I go? How far to the right, how far up do I go? How far down, how far to the left, how far down, how far to the right? And just added up the small parts, because that's where we started. We started with just things moving all perpendicular to each other. So you can take any vector and break it up into its perpendicular components. In other words, you're making the claim that instead of writing this vector, I'm just writing these 2 pieces right here. Because if I add that and that together, I'm gonna get this. That would be the equivalent of, if I'm doing 5 plus 8, well, that's the same as 5 plus 5 plus 3. I'm just breaking one of these things up into more easily manageable things. And so that's 10 plus 3, which is 13. This would be the scalar analog of adding components. I wonder how close we're gonna get. All right, so let's try this out. So pick a starting point. So I'm not gonna add the orange lines, I'm gonna add the black lines here. I'm gonna add the perpendicular components. And of course, everything has been done perfectly here, and this is gonna be recorded, because when this comes out perfectly, you're gonna see tears of joy coming streaming down my face. That's the way physics works. Did it, an impromptu, let's figure out the acceleration due to gravity in the classroom, and it should be somewhere around 9.8 meters per second squared. This is chapter 3 stuff. I did it with the class, we came out with 27. So, being far off is, you'll get used to. All right, so I'm gonna pick a starting point. I'm gonna do this right here, so I'm going to the left, that far. That puts me here. And then I'm going to the left that far. And that puts me here. So that is this and this going off to the left. Now let's do going off to the right. So we're going off to the right that far. And to the right that far. Already off. Let's see, we're going up that far. We're going up that far. Those are not going off the board here. And then we're going down that far for this vector. And down that far. So doing the exact same thing, just adding a slightly different order, you're gonna end up with a resultant that looks like that. And as you can see, it perfectly matches this one. Whenever I start these things, there's that hope that this time it's gonna work. And part of the difficulty, part of the freehand issues. All right, so back to my original question before we started this fun little journey here. What is the magnitude of this vector right here?
Is magnitude the same as direction?
No. No, it's not, you don't add them straight up, direction matters.
Is the resultant gonna be the same as the magnitude?
Is,
The resultant is the same as the magnitude?
the resultant technically is a vector with magnitude and direction. I'm just looking for the magnitude of the resultant.
Okay.
So if you wrote this out, if you sketched this out, because we said I hat was to the right and j hat is down. So this is to the right and up because it's negative. So 6 reasons to the right. 2 reasons up. What does the resultant look like? Or for the purists, like what does the resultant look?
It's 6 and some change, but I just don't know what the change is.
Oh, yeah, it is 6 and some change. If you're gonna give me change, I guess I should figure out what the change is. Okay. So what you got?
I need a new calculator.
Oh. Alright, someone describe to me what the resultant looks like. I'm not asking about magnitude, I'm just asking, if I drew up my resultant, what would it look like? In which direction does it point?
I got that it should be kind of up and to the right, somewhere between like 45 degrees and horizontal.
Okay, it would be. So it starts here and it ends there. There's my resultant. That's a right angle there. What mathematically would you do to figure out the length of this hypotenuse?
I did, 6 squared, 2 squared,
And then,
and I got, 36 plus 4, and 40, resulted.
ooh, you left off the last step,
Square.
square root of it. Yeah, it's the square root of 40, which is 6.36 or something, 6.32. If you wrote down square root of 40 newtons, I left units off. The newtons do not go under the radical. They're off to the side. So for the decimal fan, 6.32, that's sufficient.
Do you have a certain number of decimal points you'd like us to go to? 2, 3, or 2 or 3, or?
The reason I hesitate to go 2 or 3 is that, you know, if you're dealing with a number that's 50 in the thousands range, then you probably don't have to go that far. If you're dealing with something that's tiny, then yeah, you probably need to go farther. So,
It depends on the situation.
depends on the situation enough,
Okay.
which I know is vague.
No, but I get what you're.
There was, yeah, how many of you have dealt with significant figures before? Yeah. I think it was my first year here, there was a group that was working down here, and someone said, no, there are only 3 significant figures there. I don't care about significant figures in this class.
What I think,
Yeah, that it is a way of communicating the level of precision of your answer. How much of, if I, you know, my height is about 6 feet, 4.5 inches. Is it exactly 4.5? No, it's rounded off to 4.5. So significant figures tells you how, so if I write down 6 feet, 4.53267, significant figures are saying, yeah, my height's down to that exact measurement, which it's not. And also I've shrunk some of the age. So that's significant figures. And the rules might seem simple, but they can get complicated and a real pain in the butt. So I don't worry about it for Physics 110.
thanks. Oh, but you do worry about it in another class.
I marginally care about it. I care about it for the first lab and 2 other classes.
Oh.
And then after the first lab, I don't care.
Okay.
In graduate school, and actually undergraduate school, no one ever mentioned significant figures to me. It's primarily a chemistry thing, as best as I can figure. I think they're the only ones who truly care.
Okay.
All right, so, but the couple people, the 2 people who had sig figs, if they start talking to you about significant figures, you just go, get away from me. Leave. Make yourself get smaller, make your head get smaller with the, whatever the slang term is. All right, Yes, ma'am.
I'm still not understanding how you're getting the magnitude,
Magnitude is just the length.
just the length
Yeah.
of the resultant.
Yes.
So it's the same thing as the resultant.
Technically, the resultant is a vector, so the resultant officially has a direction also included.
Oh.
When I say magnitude, I'm saying I don't care what the direction is, and the answer, I just wanna know how long is it.
Okay.
So we can put down magnitude equals length.
Yeah.
We need another of the drawing one,
One of these,
yeah.
was that much fun? All right. You go with 3 or you want me to throw with 100?
Up to you.
3.
With enthusiasm, all right. So I'm gonna add them together. Head to tail method, so I'm gonna call this A, B, and C. Because why not? Which one do you wanna start with?
A,
All right, so what I'm gonna do is I'm gonna draw A down, so I pick a starting point, so if I got a big piece of paper here, I'm picking a starting point somewhere, and I wanna redraw this, same direction, same magnitude. So my length is that long, my direction is off at that angle, so I'm gonna try not to turn my wrist a whole lot, and so that puts it right there. So that should be my vector A right there. Ideally, same length, exact same direction. And now I have a new starting point. Right there. Pick another vector. Which one do you want me to do next?
B, well, alphabetical. Let's do it.
I'm sorry I labeled them, making you feel like you had to do it in that order. All right, so now I do B. So that's the length. Should be the same length and the same direction as